So last time I asked you guys to do 2-1 by yourselves. So I gave you a little videos. I mean, it was 20 minutes or whatever. Just kind of ran through some examples or whatnot and asked you to try that. You want to start with some questions here, Tessa? 5? Okay. So it says a ball is thrown into the air with a velocity of 40 feet per second. Its height in feet t seconds later is given by the function y equals 40t minus 16t squared. Find the average velocity for the time period beginning when t equals 2 and lasting 0.5 second, 0.1 second, 0.5, and 0.1 seconds. Okay. So remember, average velocity is just a slope, right? So what I'm going to do is I'm going to do this just kind of on my calculator rather than writing this down. And just to show you an easy way of kind of doing something like this on your calculator, we're using the same function over and over and over again. So I went ahead and went to the y equals and I typed in that function that it was given. And what I'm going to do now is the slope. So I'm going to do f of 2 minus f of 2.5 over 2 minus 2.5. Everybody's okay with that idea? So I can do this on my calculator by just doing the vars button. That's there under the down arrow. Go over to the y vars. From the function option, I can select y1. So I can do y1 of 2 minus, and I'll do vars, y vars, function y1 of 2.5. And the denominator, I'll have 2 minus 2.5. So just the slope, right? y2 minus y1 over x2 minus x1. So there's my first velocity. Remember, velocity is position divided by time, right? Or distance divided by time. So that's part 1, or I. And now I'm just going to go recall the same thing I had and just update this. So instead of being 2.5, it's just going to be 2.1. So there's my next velocity. And then I'll just go in and update this again. So instead of being 0.1, it'll be 0.05. My next velocity, and then update it one more time to be 0.1. Tessa, are you okay so far?
Yeah.
Okay.
Could you zoom in my calculator?
This is as big as I can make it, unfortunately. I know that's a very big bummer.
Thank you.
Yeah, no, I apologize. I wish I could make it bigger. Whatever the app that I'm using to emulate this is like as big as it'll let me make it. Yeah. That doesn't help any. I could enable sound. Would that help? Probably not. So in part B, it says, okay, what would the instantaneous velocity be? So if I look at, as we're getting closer and closer to the slope at, like 0 time elapsed, went from negative 32 to negative 26.5 or 25.6, negative 24.8, negative 24.16. What do you suppose it's going to be? Negative 24. Now, we can do that manually as well. So you can take the limit as like a approaches 0 of, if I plug 2 in, I get 16, I think, right? 80 minus 32. No. So, oh, that's 4 times. So 80 minus 64, that's 16. And I guess, so I have the point 2 comma 16, and then we'll just say x comma 40x minus 16x squared. So let's just make that an x there, I guess, instead of an a. So here we have 2 minus x. So far, oops, I don't know why I put equals there. So far, so good, Tessa? And is that x shouldn't be approaching 0, it should be approaching 2. Thank you. My apologies again. Oh my goodness, look at all you people. Let's see, Tessa, Carmen, Isabel, Pierce, come get your respective pass.
I got like I was watching Rainbow, basically.
You should have dropped it in front of him when he reached for it for all those sweatshirt comments.
I started looking at the results.
I was just saying, like, that's what I'm saying. Numbers.
So if I go and I continue on here, I'd have, 16x squared minus 40x. Guess those are supposed to be x's, not t's. Cool. Like, come on here. Plus 16 over 2 minus x. So I'll factor off a greatest common factor of 16. That gives me x squared minus, sure. 40 divided by 16 is, what is that? Who remembers? It's like 5 over 2. So far, so good. Actually, I'm going to write it this way. Instead of taking out the 16, let's just take out an 8. That'll make it a little bit easier for the thing I want to do next. Let's do that. It would still work, but this is going to look more familiar for you. So far, so good. Okay. Now I'm going to factor that. So I need the two things that multiply to give me 2 times 2, or 4, and then add to give me negative 5. So that would be negative 4 and negative 1. So we'll factor by grouping. Oops, 2x. So there's that, right? Why am I going through all this work? Why don't I just plug the 2 in? Yeah, I'd end up with indeterminate. You got it. What do you notice that I can do now, though? Yeah, kind of, right? Notice that the sign here is different, though. So to cancel them out, I just pick up a negative sign somewhere. Is that okay? And now if I plug in, I get negative 24. Did you have to go through all that? No, you could have just noticed the pattern. That's what it was trying to get you to notice. But I wanted to show you that you could still do this the same way that we had done when I did the lesson, right? Where I looked at the limit as, you know, the 2 points become the same point, and it still works out. Rita?
On a test, would you want us to do the limit?
The directions would make it clear as to what I would want you to do.
So computer.
Yeah. Elena?
Because it's set estimate, would we be able to just put 1 forward?
Negative 24, you mean?
Yeah, negative.
Yes. Yeah. Again, I just wanted to show you that you could still go through what we did in the lesson. I don't think that was the intention with how they wrote the problem, considering they had you do like all that preliminary stuff and then goes, what's the instantaneous velocity? It's like you're just supposed to be looking at the pattern of the numbers and just writing down a number, not going through all that. I just wanted to show you that you still could have.
Okay, thank you.
Yeah, no problem. Tessa, did that feel okay? And the calculator thing, when you have to do like a bunch of slopes like that, like how massively easier is that than like plugging in the number every time by hand and then like grinding out a slope formula by hand, where it's like it was all just in there. They let the calculator do all the plugging in, that way I can't screw up the arithmetic myself. Let the calculator do flawless arithmetic for me. I'll just set it up. I like that. You should too, right? Like how many easy mistakes have we made over the years of doing math, just like doing something dumb where it's just like I should have just, can the calculator just plug this in for me so I don't accidentally write down the wrong number, like copy something wrong, or like 2 times 3 is 5, or, you know, we've all been there and done those kind of things. Anyways, anybody else with questions from this? Again, I think all the questions are kind of just like this one. If you could do one, you could kind of do them all. So we're going to move into 2.7, where we're going to actually define this thing called a derivative. Guess what? It's the instantaneous rate of change. It's the thing we were just doing. So if we go back to this question of how do we find the tangent at some point P on a curve f of x, we said that we needed a slope and a point, right? What we did is we started with the idea of, okay, well, let's just find the slope of the secant line. And then we'll just move that point Q, this x comma f of x, closer and closer to our point P. And as that's happening, the slope of that tangent line, PQ, approaches the slope of the secant line, PQ, approaches the slope of the tangent line to the curve f of x at point P, right? This was the same idea from last time. So we're going to define the slope of a tangent line to some curve f of x at the point P as the line through P with the slope as follows. The slope should be the limit as x approaches a of f of x minus f of a over x minus a, provided that limit exists. Right, same idea as last time. What do we have there really? That's the slope formula, right? Where the distance between the 2 points essentially becomes, or the distance along the x-axis between the 2 points is essentially becoming 0. Okay? Or we can write it this way, and this is going to be the preferred notation. So the limit as h approaches 0 of f of a plus h minus f of a all over h. So let's look at where this thing is coming from. Yes, sir.
What is M stand for?
Slope,
Oh.
right? Because we're talking about the slope of a tangent line. Someone was going to ask it, right? Every year. That's okay.
Yeah, I got that. Thank you. Thank you.
I think keep going, though, right? Like I don't finish it up. What's the rest of it?
Wait, and then x minus x1.
Thank you.
Point slope.
Yeah. All right. So let's look at why this equation here is equivalent to the first one, right? Because they are saying the same thing. So here we have our point P. That's the point A comma f of a is what we were calling it. And we're going to just move some h units to the right. So that's adding h to the x coordinate. So the new y coordinate then is going to be f of a plus h. And what happens when h goes to 0? Q becomes p, right? So this is y2 minus y1. How come there's not an x2 minus x1?
Because the a's
Yeah, you have a plus h minus a becomes just h, right? So this thing is still just the slope formula. Tessa, you're making faces.
Can you just explain what you said about that?
Yeah, so here's our point Q, right? So Q's x coordinate is just h units to the right of P's x coordinate. That's why we have a plus h, right? So its y coordinate then is f of a plus h, right? And what's going to happen as h goes to 0? Well, Q becomes a comma f of a, which is just P, right? Because we're looking for the slope of the tangent line. We're doing the same idea, right? Like h going to 0 is the secant line is turning into the tangent line, right? When h is 0, PQ is the tangent. Everybody's okay with that? Because P and Q are at the exact same location. So if we look at this formula, this is still just a slope formula, right? y2 minus y1. And then down here, how come it doesn't look like we have x2 minus x1? Because a plus h minus a is just h. So this is still exactly the slope formula. It's just a different way of writing it. Why do we prefer this? We like having this like lurking variable that acts a little bit like a parameter that allows us a little bit more freedom here, because now every limit is just going to be the limit as h goes to 0, which makes the grinding of your limit a little bit easier, because the techniques kind of now become the same, because it's always something going to 0. As opposed to this one where like x going to a could be any number, right? Yes, Elena.
How is like for like P, how is it be a comma f of a? It's like either or depending on which one you're using.
It's okay. Can you repeat your question? I got lost a little bit.
For like where it says like P and then a comma f of a, it's like either or.
What do you mean either or?
Like depending on which version of the formula you're using, maybe we only need f of a. You're using the second one.
Well, here, this one we defined P as the point A comma f of A.
Oh, that's like the actual.
Yeah, that's the location of point P.
I definitely.
That's okay.
I wrote it down, but
That's okay. Again, if it's not clear, like ask.
it's just so many letters. It's like it's written down. I just don't know where it's comprehensible.
Yeah, it's an alphabet soup, right? Okay. So it says here to find an equation of the tangent line to the parabola y equals x squared at the point P where it's 1, 1, right? Everybody's okay? Okay. Which definition do you want to do this using? The first one? Is that what you said, or the second one?
Second one.
Okay.
Because he said that one.
So far, so good. Or I've just plugged in the formula. Okay. So f of 1 plus h, f of 1. How did I get that f of 1 was 1? Because 1 squared is just 1. What's up? Because f of x is x squared, right? So I'm just plugging 1 plus h into x squared. Like a composition of two functions. Oops, what did I do here, though? That was very bad. That's it. Yeah, thank you, Pierce. Drop that limit. You guys should yell at me every time you see me do that. Okay. So what I'm going to do next is I'm going to FOIL out the 1 plus h squared. Is it okay if I just do that in my head and I don't write down the foiling?
Yeah.
Oh boy, what did I... Yeah, thank you, Talika. Way to pay attention. Yeah, you can be louder and prouder about it too. That's okay. I won't be mad if you're just like, hey! It's okay. Lorenzo's going to enjoy listening to that video again.
Yeah, can we that's what I just said. I know, I was just repeating what you said because I thought it was a good idea.
Okay.
I think we should get a position wrong.
So now, if you look at the numerator, what do you notice you can do? Cancel the ones.
Yeah. Can you cancel the H?
Factor the h.
Oh yeah, I was around.
Yeah. So that's the slope. But what does it ask for though?
Oh, equation. Yeah.
Yeah, I would just do point slope.
So can I drop the limit after I do 2 plus h, or do I need to write that again?
So here on this step, the limit goes away because I did the direct substitution. That ends the limit, Carrie. Until you've done like a direct substitution and gotten rid of your variables, or the variable that's, the limit is in terms of, the limit should stay until all the h's are gone.
Okay.
Once the h's are gone, the limit can disappear.
All right, thank you.
You're welcome. Yes, Emma.
Is it 2 plus 0 because we're putting
Because we plugged in 0 for h. Yes, we did direct substitution to evaluate the limit.
And then the equation of the what's the y? What does that represent?
I'm just using the point slope equation for a line that we would have used like in Algebra 1. And then if you want, you can rearrange that to make it slope intercept if you want. I'm fine with leaving it just the way it is. Because equation of a line is an equation of a line is an equation of a line. The answers in the back of the book probably have it written in y-intercept, or slope-intercept. but whatever. All right, let's try the next one. That is the equation 3 over x.
Are we ever gonna use the first way, or is it always one like the preferred?
You can always use the first way. As also, I just don't.
So like, is there like a time where like you can only use the first way, or like is it always?
Well, this is an interesting question. I think that there are instances where the algebra might turn into being more convenient doing the first way as opposed to the second way. Like you may run into like, oh, look, there's some clever factoring that's really obvious this way. And like, if I try doing it the other way, I'm stuck trying to like complete a cube or something, which is something you don't know how to do. I don't know how to do it off the top of my head. I'd have to like really sit down and work on it. Yeah.
Sounds good.
Okay.
Thank you.
You're welcome. Okay. So how do I find the slope? And what is f of 3? That's 1.
Yeah, why'd you change it?
Yeah, the order, that would throw me off.
Oh. Is that bothering us? Sure. Sorry. It's okay.
It was just confusing.
It's okay.
I didn't know you could switch the colors.
I don't think you're supposed to.
Oh.
That's right. All the way from 1 over 8.
Well, we know the 0.31, or you could plug it in here. Either is okay.
3 plus H over 3 plus H.
Definitely can't cancel the 3's because of the addition and subtraction in the denominator. You could make a common denominator. That would be fine. Here's what I would do, though.
What is this common denominator? Yeah, that's just the common denominator and the denominator.
Whatever you just said, because you know this f of x. How do we get from?
Well, if I plug 3 in for x, 3 over 3 is 1. Well, what I did there is it just like cleared the fraction kind of out of the little fraction inside of the big fraction by doing it that way. That avoided me having to make common denominators and like add and subtract fractions, which is kind of the worst part. All I had to do was multiply by a constant, which I think I'd rather do than add or subtract fractions. Not that it would have been wrong to make a common denominator in the numerator, combine the like terms, multiply by the reciprocal to get it down into a single fraction, but like I did it all in one step, which is like, I think a lot easier. That's my go-to method if I have like a fraction inside of a fraction. Do you remember what that's called when you have a fraction inside of a fraction?
It's the first letter.
C.
Okay, not conjugate.
Complex fraction. Way to go,
I
Beck.
had no idea those things.
Yes, Isabel?
Could you just do it out for this one problem so we can see like what you're doing, rather than like combining your own?
Yes, just like work it out.
When you say, so what do I get when I get 3 plus h times 3 over 3 plus h? Just 3, right?
Crazy, bro.
When I do 3 plus h times -1, I just get -3 plus h. And when I do h times 3 plus h, I get h times 3 plus h, right? Is that? again, it's just about like looking for the easy way to do it.
Yeah.
Now, if you don't see it this way and you're like, I'm going to make a comment, that is fine. You'll get to the same spot. It is okay. It's just more time consuming. It's more stuff to write down. I'm trying to also, on the way of doing these problems, show you these algebraic shortcuts that you can use, that you can add into your toolbox and go, okay, oh, look, this is a complex fraction. I'm just going to kind of do this clear fraction thing Mr. Kulik taught me because it's way quicker than the alternative. Do you have to do this way, though? No. I'm just trying to
Yeah, it's better though.
it's more efficient. I don't want to say better. It's just quicker, right? It's like less to write down. You can do it almost in your head. Where if I asked you to do the same, like make a common denominator and like multiply by the reciprocal and, can't do it in your head. I can just write down this and I'll do it in my head, which is lovely. All right. So make sure we distribute that negative through the numerator. And when we combine like terms, we get negative h over h times 3 plus h. So, hey. You guys don't have to yell like that. Right? So I just took the negative sign, distributed it through the parenthesis. So the 3 becomes negative and the h becomes negative. So the negative sign distributes through the parenthesis, right? So I have a negative h and a negative 3. I combine the 3 and the negative 3, and all that's left is negative h. I then reduce the h's, and I do my direct substitution, and I get negative 1/3. So what will I write as the equation for this tangent line?
Y minus 1 equals 1/3 times x.
If I'm going too fast, just ask me to slow down.
No, it's
It just tell me that I need a minute to process. That's okay. Just tell me to pause for 30 seconds. We'll take a 30-second break. Let everybody absorb it. If it's going too fast, you can tell me that. It's okay. Even if it's not too fast for everybody, those people will not be hurt by taking an extra 30 seconds and letting that sink. Okay?
So we just leave it in point slope?
You can leave it as point slope. The back of the book probably has it written in slope-intercept form as your final answer. So if you're checking against the back of the book, you might have to, rearrange that a little bit so that you can check it against the back of the book. I would not mark you down for doing one versus the other, unless it's like a real-life story problem where it asks you somehow much later on where it's like, okay, it's clear that I need this variable by itself. But so far, so good? Again, just like what we've done, right? Just like what we did in 2-1. Same idea. So physics, if I look at a average velocity, this is what we did in 2-1, right? We talked all about velocities in our story problems. The average velocity is just the displacement, the difference in your position, divided by the difference in time, right? If my positions, one position is A and the other position is A plus H, then my average velocity is exactly that f of A plus H minus f of A over H, right?
Yeah.
So the instantaneous velocity then, at some point A, is just the same limit of the slope, right? Emma.
I have a question about the things.
Okay.
So, why did we just plug in 3 instead of 3?
Why did we plug in 3?
Because it was 3-1, which is the point, and
We only use the one.
we used that.
I did. Here's the 1
Oh.
right there. When I did f of 3.
Close enough.
Is that okay? Right? Because if I write this, I could also think about this as the point 3, comma, f of 3, right? Where the point on any function is the point x comma f of x, right? Because f of x and y mean the same thing, right? We use y equals and f of x equals interchangeably. Does that feel okay? Or you could think of plugging it in, right? Like we did here. Either way is going to give you the same thing. It's not wrong to think about it either way. Okay? Sure. All right. So let's look at a physics-y situation here.
It's the same equation that we were using earlier.
Yes, that is the takeaway. That the instantaneous velocity is the same thing as the slope of your tangent line. That's the takeaway. That those two things are the same thing, right? The instantaneous velocity from your position function is the same as the slope of your tangent line in general. Yes. Okay. Suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above ground. What is the velocity of the ball after 5 seconds? Physics students. What is our equation of like a one-dimensional motion there, or something falling? Right? I should say S of t. Yeah, I would not expect you to have one half gravity. Yeah, 1/2 AT squared. Yes. Would you prefer me to write it that way first?
Are we gonna be expected to like know this stuff?
No.
Okay.
No, Talika just asked that. No. The expectation is you haven't taken physics yet.
S of t is just representing final velocity, right?
S is the position function name. So usually we use S for position, V for velocity, A for acceleration. But S is the canonical number for a position function. Okay. So you do just S of 5. And what do we get there? That comes out to be like, oh, but that's our, yeah, okay. So we do that. 123 is what you say? Okay, let's. Yeah, 1225. Okay, so our velocity then, yes, meters, no, because that's a position, right? S is a position function, not a velocity function. Yes, S of 5 plus H minus S of 5 over H. I know. We're not. Those S's are going to be out of there in a second. Is that a what?
So five plus h. Wait, oh, it's s. Mine is s of 5.
In the parentheses, 5.
Mm-hmm. So S of 5 plus h is going to be 4.9.
Do we not need the limit? Or do we need the limit?
Yes, we need the limit. Of course we do. How come you didn't yell at me? You're supposed to go, ah! Thank you. When you have to really sell out and really yell like you mean it, that's how I know you know. Because you're not going to yell if you're not sure, because then it's embarrassing. It's like, what are we yelling at? There's no problem. So far, so good. Okay. What's that? H squared plus 49h plus 2. I foiled that out, so I have h squared plus 10h plus 25. When I distribute the 4.9 through, 10 times 4.9 is 49, and 4.9 times 25 is the 122.5. Yeah, that's a 49.
Well, how would length plus h always end up being squared, like the second section of the problem?
How come will this always be something squared?
Yeah.
No, because if we look at the last one, it was like something over x, right? It has to do with the function.
They don't give us the y. How do you know? They have.
You have to have the y somehow. This one we wrote our own, right? That was the point of writing s is equal to 1/2 at squared. Because that's our s that we use to plug in, right? That was the function. So those guys cancel each other out, right? And then I can reduce the h's. Yes, Rita.
Shouldn't we have 4.9 before the h squared?
Oh, sure. Thank you. Good call. Okay. And so when I do my direct substitution, I get 49, and that's now meters per second, because that's a velocity. So that is our V of 5. Can I show you alternatively a different way of thinking? So let's say instead of just wanting V5, this problem asks for V1, V2, V3, V4, V4, or V5. Rather than doing this process 5 times, because that's dumb, this is what you would do. I would do it once for like a parameter A. So I'm going to do like V of A. And then kind of do this the same way. Just to kind of show you how this is how this would play out. We're doing part B in a second. I didn't forget about it. I just wanted to address this issue because this can become a colossal pain in the butt if we're asking for a bunch of different velocities all at the same time, right? So those guys can cancel out. And then I can reduce out my h's. What's up?
What's that last term?
4.9, yep. A squared, 4.9a squared was the last thing we had written there. So now, if I want, I have v of a equals 9.8a. So if I wanted v of 2, I just plug 2 in for a. If I want v of 7, I plug 7 in for a. If I want v of 15, I plug 15 in for a. So if I have to do a bunch of velocities, I would do this once with a general a, and then I can just plug in what a is afterwards if I have a bunch of them. If I have just one a to do, it doesn't really matter doing it this way or the other way. Same amount of work, right? But if I have a bunch to do, boy howdy, that's helpful, right? Because you looked at me when a second, I'm like, what if I have to do v of 1, v of 2, v of 3, v of 4, v of 5, and you looked at me like, oh my God, shoot me in the face. No, it's not so bad. You just do it once, and then you plug in. Yes, absolutely. Okay. We still have to talk about part B, though, correct? Because this was just like a step aside. Part B asked, how fast is the ball traveling when it hits the ground? So how do I do that? I go back to my position function to solve for the time in which the ball is on the ground, right? So how do I solve S of t equals 4.9 squared? What position will the ball have when it's on the ground?
0.
Well, I needed to travel 450, or right?
So
It doesn't matter because if it's like accelerating up or accelerating down, it's going to be the same amount of time as long as that acceleration is the same. So if whether you think about it like going up to 450 or like down to -4, it doesn't really matter. So we're just going to say that 450 then is what S of t has to equal. So I have 4.9 t squared. So t should be the square root of 450 divided by 4.9. So far, so good. So that's about 9.6 seconds when you type that into your calculator. So then I do V of that 9.6 and boy, wasn't it nice that we also did that velocity the general way so we could just plug in the 9.6 into that? Yeah. It was.
So would you recommend doing it the general way?
I mean, I always do it the general way because you don't know how many times you might have to use it in a problem. But if it was like just the generic, like write the tangent line for this thing, like we've done before, you're not punished in any way for not doing it the general way. It's really no different. But for a story problem, yeah, I'm always going to do it the general way just so that I don't have to do that limit thing more than once, because you might end up with some part you didn't expect to need to use it, or you had to use it, like in this one. Emma. 94 meters per second is the velocity when the thing hits the ground. That's how fast it's going. Everybody's okay here? Okay. So, new definition then. We call the derivative of a function f at a number a, which we denote as f prime of a. So like that guy we read as f prime as the slope of this tangent line thing that we've just been doing. So the derivative at a point is exactly the slope of the tangent line at that point. And again, we can think about it either way, right? Remember we had two ways to represent that slope of a tangent line? Which one do you suppose we use more often? Yeah, this guy we use most. Yeah. So far, so good. So let's say that we want to find the derivative of the function f of x equals x squared minus 8x plus 9 at the number a. Well, I'm just going to use that formula from above. So far, so good. That's the name of the derivative. So the derivative of f at a is f prime of a. Always. That'll be a standard notation. Yes. That's the name we give for the derivative of a function. One of the names, anyways. We have lots of ways we'll represent those. We'll look at that more, I think, in the next section. Okay. What is f of a plus h going to be in this case? So what f of a plus h, how am I going to write that?
A plus h squared minus 8 times a plus h.
Plus 9. Sorry. And then what is f of a going to be? How am I going to write that?
A squared minus 8a plus 9.
Everybody agree with what I've written here? You're wrong!
Oh. What?
What's the mistake?
The h? Parentheses?
Because that negative sign
Oh.
is going to have to distribute to each term. Easy mistake to make.
Yeah.
Why I'm making a big deal and yelling right now, to get everybody's attention so I can talk about this mistake. Because, whoa, baby, that's an easy one to make. Tessa. Of course. Okay. All right. Let's keep going. So I'm going to FOIL out the a plus h squared, distribute through the negative 8, and then distribute through the negative. And it looks pretty bad, but this is just the darkest before the dawn, because it's about to get a whole lot better. Yeah, look at all the stuff that's going to cancel out. A squared and negative a squared. Okay, no problem. Yeah, it's beautiful, isn't it? Like it just works, like everything just works exactly like it needs to. And it's lovely, lovely, lovely. Elaine, am I good?
Yes.
Okay. A squared, negative a squared. See you later. Negative 8a, positive 8a. See you later. Positive 9, negative 9. See you later. Notice the only things left contain a factor of h. So let's just reduce those. And we're left with the limit as h approaches 0 of 2 plus h minus 8. Oops, I'm sorry, that's not right. That should be, yes, thank you. This guy right here was supposed to be 2AH. Thank you.
The one that is
In blue. No, it's fine. So we do our limit then. What's this limit turn into? So at the end of the day, I will say that f prime of a is 2a minus 8. Trevor, I mean, no, you're not Trevor, Jacob. Of course. I got too many Tuttles. Yeah, what's up, Rita?
Wait, I just like. So wait, we have 2AH.
I made a mistake. It should have been 2AH.
Oh yeah.
Pierce caught it, right? Was that you, Pierce, that was saying?
It was.
Okay. Make sure we credit where credit is due. Again, you can yell bloody murder if you think there's a mistake.
Wait, then how'd you get 2A plus H? Or, okay. 2A.
Right, but the H canceled,
Oh.
right? Because the H still cancels there.
Oh yeah, within this count.
Yep. So that stuff in green is the stuff that's left. Okay. All right. We just got a little bit left here. So again, in the pink box here, this is just the observation that we made initially, right? That the slope of the tangent line and the derivative at A are the same thing. So if we have then if we want the equation of the tangent line for this at the point 3, -6, I'm just going to do f prime of 3, which we have. And I can do y minus y. This was the same function as before, right?
Oh, it's like the same question?
Yeah.
So in order to get to this, so we have to do all of that, it was just one problem.
If it was just one problem, yes, you would have had to do all that stuff. But like, I'm not redoing it. Why would I redo it?
That makes sense.
You know? What's up?
Oh, never mind.
Because it's just too many bikes.
Boom, done. The hard part was
The first one.
getting the equation for the derivative, right? Or that general form for the derivative. But once we have it, I can use it like a function and find the slope for any a, the slope at any point a along that same function. So if I had to come up with lots of equations for tangent lines, I could just keep reusing that derivative over and over and over to generate those new slopes and not have to repeat the limit process over and over and over again. Yes! Isabel,
Why did you add the 9?
why did I add the 9?
It was like every time 3 is equal to 2 thirds minus 8, but then what happened to the 9?
Well, this is the f prime of a. Where's the 9 in that?
Real high. The equation and the 3. Oh, you don't use that. We found the equation in 1. Oh, yeah.
We did that part already, and then we used this part right there. Is that better highlighting? I'll use a different color. Okay. So slope of a tangent line, same as derivative. Remember that our difference quotient, the slope formula, the equation, or the slope of a secant line, all these things, the average velocity or average rate of change, all of these mean the same thing, right? Average rate of change, slope of secant line, difference quotient, all talking about the same thing. Just 3 words that mean the same thing. Remember the instantaneous velocity, the same as the slope of the tangent line, the same as the derivative. So the instantaneous rate of change is the same as, we're just going to stick the limit on our difference quotient. And what does this look like? That was the other version of our equation for the slope of the tangent line. Right? Let's just go back and look real quick. Right? Isn't that just the same as this? Right? It's just the same thing. The instantaneous rate of change is still going to just be the derivative at some point A.
So can we use the other?
Absolutely! Yes, absolutely. Use whatever version you'd like. Yes, of course. They're interchangeable. They do the same thing. Use the form that you like. Yes. Yes. The point of today was this. All these things are just the same thing. They're all just the derivative. Instantaneous rate of change, slope of a tangent line, instantaneous velocity. They're all just the derivative. Cool.
That's great.
Let's do a quick little example here. So manufacturer produces bolts of cloth with a fixed width. The cost of producing X yards of fabric is the function C equals f of X dollars. What is the meaning of the derivative of f of X? What would its units be? So, if they're ever asking you what is the meaning of a derivative, it always starts, it's the instantaneous rate of change and now we're going to tie into the function that we're given specifically. So, which is the y value? C. With respect to, what's the independent variable? X. So what does that mean? In other words, yes, it's the instantaneous rate of change of the cost of production with respect to the yards of fabric produced. So the units here would be dollars per yard. Everybody's okay? Part B, in practical terms, what does it mean to say that f prime of 1,000 equals 9?
Like 1,000 yards of fabric. It's not that costs $9.
Per yard. So I would say it costs $9 per yard when producing 1,000 yards of fabric. Oops. Oh, come on now. Now, typically in a business, what happens with production?
The more you produce, the cheaper.
The more you produce, the cheaper things get. Now, it's usually like tiered, right? So like goes down and then it goes back up, but then it drops slower. Why would it have a spike all of a sudden? Might have to build a new factory or something like that. There's a huge initial cost, but then the production goes way down again. And then part C, which do you think is greater? F prime of 50 or F prime of 500? What about F prime of 5,000? Economics students? I would expect this relationship that the more you're producing, the cheaper it gets, right? The cost of production should be going down as the amount you're producing goes up.
So is that all we have to do with that? Right?
For something like this, were you given a function f of x? No, you weren't given something specific, right? Just f of x is just generic f of x, right?
Okay, that's very nice.
So like you can't really do any math with this. You just do it, you know what I mean? I'm going to skip this last problem in the interest of time. So your homework for next time is down here. We got some boldies. What's that mean? Homework quiz. What is the big takeaway though today?
It's all the same.
It's all the same thing, right? It's just all the derivative. Just take the derivative.
What page is this on?
Let's see. Would be about 150 in the PDF, or in the book page is 150, and maybe it's like 182 or something in the PDF or something. I think if you just do 150 though in your PDF up at the top and press enter, it just should go bloop right to it. Do you not? I always. This PDF is really nice in that it's just as a point. This PDF is really nice because it's bookmarked. If you don't have the bookmarks open, like you can go and just straight to 2.7 and not have to look for stuff. Anyways, Isabel.
I was going to ask you to put the homework.
Yeah. I just wanted to show how easy the
It's like a wave.
Yeah.
It depends on where you took it.
Yeah, yes. It'll come today. It'll reach you guys. Yep, I haven't checked my phone.
Maybe you should.
It'll come
it might be different if you're taking do the essay also.
Yeah, if you do the essay. Did you do
Just-
the essay? Did it come out?
Yeah, let me check.
How are the fragments?
What came out? ACT.
Oh, yeah.
So I was missing.
Let's get this over, you know? I hope I did better than I feel like I did.
Oh, yeah, you're totally
Same
probably
time. I think English was
If they don't come out by like Monday, next Monday, like give it a
Yeah.
why the why October?